In these two following pictures, you can see the tailwheel assembly itself. The wheel is supported on a carbon fibre axle, and the arm supporting that is two strips of styrene bonded together with cyno. The vertical rod is also carbon fibre, as is the horizontal axis that sits inside the plane. It's on an aluminium shaft, and that's bound to the vertical rod with cotton thread and thin CA wicked into it. The two little yellow parts that you see on the end are some air hose line that I cut rings off of and cynoed from the outside so that the aluminium rod can't slide side to side. And then at the very top there's a control horn, which again is made from thicker strip styrene compressed around and all bonded together with cyno. Then ultimately the clevis pokes through a 1mm pinhole that was pre-drilled and is bonded onto the carbon fibre shaft. This whole assembly weighs less than 2 grams. Here we have the mock-up with the fin and elevator linkage held in place, so we can see where the 3 different push rods align. I'll show this again in just a moment without the fin in place. But essentially we have 3 push rods running into the back. From above in here you can see the linkage going onto the bottom of the fin. I'll show this separately in just a moment. And here we've got the elevator control bar, and its push rod is just here running through this sleeve, and this is off-centered, which allows it to clear the tail wheel. Here is the fin linkage. It's a normal arm. I've drilled through and run a plastic sleeve out of PTFE along the bottom here, and then at the final step soldered on a brass horn and attached the clevis ready to be glued to the push rod at the same time the fin is glued into place. Inside here we can see the 3 push rods coming through. On the left hand side here we have the rudder, which terminates just here. This is where the sleeve will come on. Down the centre through the gap there we can see the top of the arm for the tail wheel running onto a centre push rod here, which runs back. Then we have the elevator push rod running through, and we completely plaster sleeve ends here, and this goes onto this, which again will be glued. Later the push rod stays in place, the clevis stays attached to the horn, the clevis will be epoxy bonded onto the rod at the same time that the whole tail assembly is assembled. At the bottom, without the fin in place, we can now see the pivot for the tail wheel is cynoed underneath the 2 spars at the side, which adds some strength to help it take the load. So this carbon rod axle is fixed in place. The aluminium sleeve is free to turn. The rod pokes out through the bottom, and the clevis is attached on top. Now this centre push rod is finalised, it's glued, it's epoxied in place, it's not going anywhere. You can see how these work down the aircraft. At each former we've got a 1mm carbon spar running sideways, which is cyno glued onto the push rods to stop them bending. If they bend, obviously the load taking of the tail wheel will fail, as the push rod is under compression, so it will bow if it's not supported, and you lose that tension, so the servo will move and the tail wheel won't take the weight of the tail of the aircraft. These run all the way down, eventually level out, and then in our servo section we've got a 3D printed servo tray, 3 servos. At the far side we've got our rudder. In the centre we've got our tail wheel, and just like the main undercarriage, it's locked straight for tail wheel down, so that there's no load being imparted onto the servo, and then it bends to 90 degrees to raise the tail wheel, which on the radio one I can show you here. So as the tail wheel comes up, the servo pulls. I'll film the same from the opposite end. We now see the tail wheel has come up. I'll grab the radio. Tail wheel down. Works like so. And this side here we have the elevator running the tail.